Welcome to Ask and Learn.
Hi, I'm going to solve question 11 from section 9.1 of SUR's calculus. This question asks us to show that these two graphs cannot be a solution of the given differential equation. For solving this question, we don't need to solve the differential equation. We just can use the properties of the first derivative. If you have a graph of a function, what does it mean? The first derivative at each point to that graph. If you consider a point of the graph, for example, x equals to 1, the derivative of the function at x equals to 1 is the slope of a tangent line at that point to the graph. The tangent line is a straight line which touches the graph at that point. Here, the slope of a tangent line is positive. It means that the derivative of this function at x equals to 1 is positive. Now let's return to the differential equation. We know that e to the power t is always a positive function. And also y minus 1 squared is always positive. It means that the derivative of the function at each point is always a positive value. So the tangent line at each point of the solution of this differential equation has a positive slope. But in graph A, it is not the case. If we look at, for example, this point, the tangent line is decreasing. It means that the slope of the tangent line is negative. In other words, the derivative of this function is negative at this point. So graph A cannot be a solution of this differential equation. What about graph B? Again, we return to the differential equation. Consider y equals to 1. At this point, dy to dt, or the derivative of the function, equals 0. It means that if we have a graph of the function, the tangent line at y equals to 1 and some point t should be a horizontal line. But if we consider the graph B at y equals to 1 and some t here, the tangent line has a positive slope and it is not horizontal. It means that the derivative of this function is not 0 at t0 and 1. So graph B cannot be a solution of this differential equation.